Hello, everybody, and welcome to section 3.1, extrema on an interval. What is extrema on an interval? We're going to get to that. We'll do that during synchronous. But one of the key things on finding extrema on an interval are these things called critical numbers. So that's what we're going to focus on in the asynchronous part. It's very important. As a matter of fact, it's critical that you have good understanding of what these are and how to find them. So the definition is really, really simple, but you really have to pay attention to every part of it. It says if you have a function that's defined at C, so first of all, this is kind of big. If the function is not defined at C, there are no critical numbers. If f prime of C equals 0, if the derivative of C is 0, or if it's not defined at C, so we're talking about the derivative, then C is called a critical number. So basically, to find a critical number, take the derivative and find out where it equals 0 or it's undefined. But be careful. The derivative sometimes is undefined, but the function's not defined. So you have to make sure when you establish, say, x equals 5 is a critical number, it's only a critical number if 5 is defined in the original function. You'll see that come up in some of these problems I give you, I hope. So we're going to do 4 problems to find the critical numbers. They're also called critical values, in case you see that. So the first one. As you're watching these videos, as I always suggest, if you think you know what you're doing, don't wait for me to do it for you. Pause it, do it, and then check. So this first one, to find the critical numbers, we have to find the values that the derivative of the function is 0 or undefined. So to do that, we have to find the derivative. Now again, we have to find out whether this is equal to 0 or undefined. This is never undefined, it's a polynomial, but we can't find out where it equals 0. So to solve this, do it by factoring. If there's more than one x in your equation, do it by factoring. Best thing to do here is to factor out a common factor of 4x squared. I believe that's true. And in a video I do after this, I'm going to show you how to check these things. So we'll be able to check this later. So now we've find out where each factor equals 0. 4x squared equals 0 when x is 0, and this would be x equals 3/10. So since those are the two values that the derivative does equal 0 are critical numbers, and critical numbers are always x values, and that's it. So let's go on to the next one. All right, so now they're getting a little bit more complicated. We have to find the derivative. So this is good practice with derivatives. Again, pause this maybe and determine the derivative. About 21 plus. Oh, that's right. All right. So we have this. This derivative is undefined. So critical numbers are where the derivative is 0 or undefined. I'm going to find that x equals -7. It equals 0 when the top equals 0. But the top doesn't equal 0, so you can ignore that. So the only place that this derivative equals 0 or undefined is -7. It's undefined at -7. So that would be a critical number, except you have to check to make sure it's defined in the original problem. So if you plug -7 into the original problem, you're going to see that it makes it undefined. Therefore, there are no critical numbers. Since the only one that we found makes it undefined. All right, so I'm going to end the video here and go to the next two in a new video so it doesn't get too long. Here are the next two coming up. As a preview, you just may want to do this. I'm not going to spend time. This is a product rule. I'm going to go to Wolfram Alpha. You may want to practice that, do it, and then check to see what I have in the next video. So I will see you then.